Section 12.7 is on the probability of compound events. In this lesson, we're going to take a look at 4 different situations. The first is the probability of independent events. If the probability of one event occurring is not dependent on the other event, then to find the probability of both events occurring, multiply the probabilities. So the probability of A and B happening is equal to the probability of A happening times the probability of B. Let's take a look at an example here. So we have a bag that contains 3 red, 5 blue, and 6 yellow marbles. A marble is selected, replaced, and then a second marble is selected. We need to find each probability. So the first is, what is the probability of drawing a red marble and then a blue marble? So that's going to be the probability of drawing a red times the probability of drawing a blue. Now the probability of drawing a red is 3 out of the total number of marbles, which is 14, times the probability of blue, 5 out of 14. Now just put that into your calculator. You can do, actually the easiest way to do it is 3 divided by 14 times 5 divided by 14. Or if you just want to do it the old-fashioned way of multiplying across, that would be 15 over 196. Punch that into your calculator. You're going to get a decimal 0.08 something, which is approximately 8%. Second example, what's the probability of drawing a yellow marble and then a marble that's not red? So that's going to be the probability of yellow times the probability of not red. So the probability of a yellow marble is 6 out of 14 because there are 6 yellow marbles, and the number of marbles that are not red would be the number of blue plus yellow, or 11 out of 14, and that's equal to, if you do a little canceling, you'll get 33 over 98, which is approximately equal to 34%. Here's another example. So there's a 30% chance of rain in Paris and a 40% chance of rain in New York. What is the probability that it will rain in both Paris and New York? Notice that it raining in New York is not at all impacted by whether or not it's raining in Paris. Those cities are far enough apart that they're two completely independent events. So the probability of rain in Paris is 30%, and so I'll write that as a decimal, 0.3. times the probability that it's going to rain in New York, which is 40%, and I'll write that as a decimal as 0.4. Those multiply to 0.12, which is equal to 12%. So there's a 12% chance that it will be raining in both Paris and New York. Second one we're going to take a look at now is the probability of dependent events. If the probability of one event occurring is dependent on another event, then multiply the probability of the first event by the probability of the second event occurring after the first. So that's the probability of A and B occurring is equal to the probability of A times the probability of B occurring following A. Let's look at an example. So we're going to look at the same bag of marbles. We had 3 red, 5 blue, and 6 yellow. But this time, once we draw a marble out, it is not replaced. Remember, in the previous example, we put the marble back in the bag. So our total number of marbles always remained at 14. Now, once I take a marble out, I'm not going to put it back in there. So we need to find each probability. So the probability of drawing out a red and then a yellow. So the probability of drawing a red is 3 out of 14. Okay. And now that I've taken a red marble out of the bag, there are now 13 marbles in the bag. So now the probability of a yellow is 6 out of 13. That's equal to 9 over 91, or approximately a 10% chance. Notice that when I don't replace the marble, the total number of marbles in the bag is decreased by 1 each time. Example number 2, what's the probability of drawing a blue and then a red and then a yellow marble? So the probability of a blue marble is 5 out of 14. The probability of a red is going to be 3 out of 13 because there's 1 fewer marbles in the bag. And the probability of a yellow is going to be 6 out of 12. Punching that all into your calculator, you get approximately 4%. Example 3, what's the probability of drawing a blue marble, another blue marble, and then a red? So the first blue is going to be 5 out of 14, because there's 5 blue marbles and a total of 14. Now the second is clearly going to be out of 13 because I didn't put that first blue marble back. But I've already taken one blue marble out of the bag, so that means there are only 4 left in the bag. And then that's going to be times red, which is going to be 3 over 12. Remember, continue to decrease your denominator by 1 each time you draw out a marble. And that's approximately equal to 3%. So the 3% chance that I'll draw a blue, and then a red. My last example here, what's the probability of drawing a red and then not a blue? So there are 3 out of 14 red marbles. And then how many not blue marbles are there? Well, there's 5 blue, so there's a total of 3 plus 6 or 9 not blue, but I've already taken a red one out, which is not blue, so there's only 8 not blue marbles left in there. So 8 out of 13, and that comes out to about a 13% chance. Our next situation is the probability of mutually exclusive events. To find the probability of 2 events that cannot occur at the same time, we're going to add the 2 probabilities. So what is the probability of A or B happening is the probability of A happening plus the probability of B. Notice this time I'm only doing one thing. I'm only drawing, like for example, one marble or one thing happening. So what's the probability of this happening or that happening? Here's an example. A die is rolled, and what is the probability of rolling a 2 or a 4? So the probability of a 2 or a 4 is going to be equal to the probability of rolling a 2 plus the probability of rolling a 4. So the probability of rolling a 2 is 1 out of 6, because there's only 1 2 on a 6-sided die, plus the probability of rolling a 4, which is also 1 out of 6, which is equal to 2/6, 1/3, or approximately 33%. Here's another example. A card is randomly chosen from a standard deck of cards. Find each probability. So what's the probability of drawing a 3 or a 4? So that's going to be the probability of drawing a 3 plus the probability of drawing a 4, because those are 2 exclusive events. They cannot occur at the same time. Probability of drawing a 3 is 4 out of 52, because there are 4 3s out of a total of 52 cards in the deck, plus same thing for 4, there are 4 4s in the deck out of a total of 52. That's equal to 8 over 52, or 2 over 13, or approximately 15%. Okay. Second example, what's the probability of drawing an ace or a face card? So that's going to be the probability of drawing an ace plus the probability of drawing a face card. And again, these 2 events cannot occur at the same time. A card cannot be both an ace and a face card at the same time. So the probability of drawing an ace is 4 out of 52, because there are 4 aces. And the probability of drawing a face card is 12 out of 52. Now remember, the face cards are the kings, queens, and jacks. And there's a king, queen, and jack of each of the suits: hearts, diamonds, spades, and clubs. So that's a total of 12 face cards. So that's 16 out of 52, 4 out of 13, or approximately a 31% chance of drawing an ace or a face card. And the last situation we're going to take a look at is the probability of mutually inclusive events. So to find the probability of 2 events that can occur at the same time, we're going to add the 2 probabilities, then subtract the probability of both occurring at the same time. So the probability of A or B occurring is going to be the probability of A plus the probability of B minus the probability of A and B. And let's take a look at some examples. So again, we have a standard deck of cards, and we're going to choose one card out of that deck. Find each probability. So what is the probability of drawing a heart or a queen? So that's going to be the probability of drawing a heart plus the probability of drawing a queen. And now we need to ask ourselves, can a card be both a heart and a queen at the same time? And indeed it can. There is one queen of hearts in the deck. So I need to subtract the probability of drawing the queen of hearts. Okay, so there are 13 out of 52 hearts in the deck, plus 4 queens in the deck, and there is one queen of hearts, so I need to subtract the queen of hearts. So that's going to give me 16 over 52, which reduces to 4 out of 13, which is approximately 31%. So you're probably wondering, why do we have to subtract here? Because the Queen of Hearts is actually, when I'm talking about these 13 cards here that are hearts, the Queen of Hearts is one of those. Then when I'm talking about these 4 cards here that are queens, the Queen of Hearts is one of those. I can't count it twice. I can only count it once. So I have to subtract one of those occurrences of the Queen of Hearts being in the probability. And let's take a look at one more example here. What's the probability of drawing a black card or a king? So we need the probability of a black card plus the probability of a king minus the probability of a black king. Okay, so in the deck there are 26 black cards. That would be 13 clubs and 13 spades. There are 4 kings. Okay, and of those 4 kings, there are 2 black kings. That would be the king of spades and the king of clubs. So that's going to give me 28 out of 52, which reduces to 7 over 13, or approximately 54%. And again, when I'm talking about counting all of my black cards here, there's a king of spades and a king of clubs in there. When I'm counting my kings here, I have a king of spades and a king of clubs, and I can't count them in both places. So that's why I have to subtract 2 black kings from this. So in this lesson, we took a look at several different types of probability of compound events, of independent events, of dependent events, and of mutually exclusive and mutually inclusive events. The first 2 examples that we talked about, notice they use the word and. And anytime you see the word and, maybe I'll add this to the notes here. If I'm doing this and that, I'm going to be multiplying. And then notice in our second 2 examples of the mutually exclusive and inclusive events, I use the word or. What's the probability of drawing a queen or a heart? And in those cases I had to add, and sometimes I had to subtract if both events could occur at the same time.